Good evening and welcome to this channel. This is Engineer Samanik and welcoming you to this physics lecture. In this lecture, we'll be looking at specific heat capacity. We'll be looking at specific heat capacity, the method of mixture. This is our lesson 2 of our series on specific heat capacity. So in case you've not subscribed to this channel, please make sure you subscribe and like the video. And if you have any comments, you can connect with me via my WhatsApp or my Instagram account. Okay, this is my WhatsApp number. This is my Instagram account, Edison for real. This is my WhatsApp number. So you can always connect with me if you have any need to connect with me. Okay, so like I said, we've already had lesson 1. In case you missed lesson 1, make sure you go over lesson 1 before starting with lesson 2, so that you will actually benefit greatly from the class. So let me share the lesson right away. Let us commence right away. So, good day, hello and welcome to this lesson. This is a physics lesson. This is lesson 2 of our series on specific heat capacity. In our original lesson, we did explain the concept of heat capacity, specific capacity. Now we just want to explain how the specific capacity of a substance is measured, and we're going to also look at some calculations on specific heat capacity. So the measurement of the specific capacity of a substance is based on the law of conservation of energy, the principle of conservation of energy, which states that energy cannot be created nor destroyed, but can be converted from the apparatus that is used, and the methods, they rely on the principle of conservation of energy. The apparatus that is used in measurement of specific heat capacity of a substance rely on this principle of conservation of energy. Okay, the experiment actually involves heat transfer between two bodies using a device known as a calorimeter. The device that is used is called a calorimeter. So specific capacity of a substance is measured in a device. Actually, the experiments are done in a device called a calorimeter, and the process through which this is done is called calorimetry, or the method of mixtures. The method of mixtures actually uses the principles that heat loss is equals to heat gain. It uses the principle of what? That the heat that is lost is equal to the heat that is gained. And please, if you not watch the first lesson, I would like you to go back and watch the first lesson. The link will be provided in the comment section, in the description section. Go back and watch that first lesson so that you can easily follow this lesson without any problem. So like I said, when a hot material is mixed with a cold material, what happens? In an insulated container, the insulated container is what we can call the calorimeter. The hot material is going to lose heat, while the cold material is going to absorb heat from the hot material. The hot material will lose it to the cold material. The cold material will absorb heat from the hot material. So the hot material loses heat while the cold material absorbs heat. Now, if no heat is lost to the surrounding, if that container is well insulated such that there is no heat loss to the surroundings, what happens is that the heat lost by the hot material is equal to the heat gain by the cold material. That is just the principle of the method of mixture, the principle of the process of calorimetry, the process of the method of mixture, how it operates, how it pans out. Okay, so we are going to, okay, let me just quickly explain one or two things here. So the this thing, the measurement of the specific capacity of the body is based on the law of conservation of energy. The apparatus that is used, the device that is used is called the calorimeter. The process by which this calorimeter is used is called calorimetry, or the method of mixtures. And the method of mixtures use the principle of that heat loss is equals to heat gain. Heat loss by the hot body is equal to the heat gain by the cold body, by the body at a lower temperature. So let me quickly explain this. I'm going to throw more light on this before we continue. So right now I'm going to explain how the method of mixtures can actually be used to calculate, to estimate the specific capacity of a substance. So let's take for instance that we have a block of copper of mass 0.5 kilogram at a temperature of 100 degrees Celsius. This copper is at this temperature, and we have water at a temperature of 25 degrees Celsius. We have 0.6 kilogram of water in an aluminum calorimeter. Okay, let me still use a copper calorimeter. A copper calorimeter. Okay, and the mass of the copper calorimeter, let's take it as 0.8 kilogram. That is the mass of the copper calorimeter. So take it now. We have water of temperature 25 degrees Celsius. The mass of the water is 0.6 kilogram. Contained in this copper calorimeter, the mass of the copper calorimeter is 0.8 kilogram. Now, the initial temperature of water is what? 25 degrees Celsius. Since this water is contained in this calorimeter, the initial temperature of the copper calorimeter as well is going to be 25 degrees Celsius. Okay, so the temperature of copper is 100, higher than the temperature of water, the initial temperature of the copper calorimeter. So which device is going to gain it? Which one is going to lose? The copper solid is going to lose it because it is at a higher temperature of 100. While the copper calorimeter and the water in it are going to gain heat because they are at an initial lower temperature of 25 degrees Celsius. 100 is bigger than 25. So there will be a transfer of heat from the copper block to the copper calorimeter and the water inside as well. So at the end of the day, by the method of mixture, by the process of calorimetry, the heat lost by the copper block will be equals to the heat gain by the copper calorimeter plus the water inside the calorimeter. So we're going to have heat lost by copper block is equals to heat gain by copper calorimeter plus the water inside the calorimeter. Okay,
is the heat gain by
so
the
now,
water inside.
how do you calculate the heat loss? You are going to know the specific capacity. You are looking for, let's assume we want to calculate the specific capacity of copper, we don't know it. Okay, but we know the specific capacity of water. We know the specific capacity of what? Of water. That of water is 4,200 joules per kilogram per Kelvin. Okay. Also, we know the specific capacity of copper. Definitely, it's fixed. This is something that is fixed in table. But let me take a scenario that this solid, we don't know the material it's made of. Let me just take any solid, a general solid. I don't know the material it's made of. But the calorimeter is made of copper. The specific capacity of copper is 380 joules per kilogram per Kelvin. So this is a general solid. We don't know whether it's copper, whether it's aluminum, we don't know the material is made of, but we want to calculate the specific capacity. So now, the heat, to calculate it, you need to know the mass times the specific capacity times the temperature change, theta 2 minus theta 1. Okay. So this is going to be the mass of the solid, which is given as 0.5 kg, times the specific capacity, which we are looking for, we don't know. Then the temperature change. Okay, before we get to the temperature change, when you mix this body, when you put this block inside this calorimeter, inside the water in the calorimeter, what is going to happen is that it's going to lose it. The water will not absorb it. The copper calorimeter will absorb it, while the solid you have introduced will lose it. So its temperature is going to decrease from 100. While this temperature of the calorimeter and water inside will increase from 25, it will start rising. Then it will get to a particular value, and there will no increase anymore. There will no decrease for the solid at that point. While the water and the calorimeter will not increase anymore. They will not be in equilibrium. There will be an equilibrium temperature. That value, where there will be a uniform temperature now. So at that point now, let's assume that that temperature is that occurs is let's say temperature of 52, the final temperature of the mixture. So this is going to be, to calculate the heat lost by copper, this is going to be mass of copper times the specific capacity of copper times that final temperature, the initial temperature of the, sorry, not copper, we're not looking at copper anymore, we're looking at the general solid, so let me change that to a solid block. So that will be the mass of the solid block times the specific capacity of the solid block, which we don't know we're looking for, times the temperature, 100 here minus 52. So this is going to be 100 initial minus what it drops to 2. M here is 0.5 times C, the specific capacity of the solid, which we don't know, which we are looking for. Now for aluminium, for copper, the copper calorimeter is going to be the mass of the copper calorimeter, which is 0.8 here, times the specific capacity of copper calorimeter, which is 380 joules per Kelvin, kilogram per Kelvin, times the temperature difference. The copper calorimeter was at the temperature of water, which was 25. It now rises to 52. So there's a difference of 52 minus 25, which is 27. So this will enable you to calculate the heat gain by the copper calorimeter. Okay? So we have this value, we have this value, we have this value. Okay. So next is to calculate the heat gain by water. So the heat gain by water is going to be the mass of the water, MW, times the specific capacity of water, which is 4,200. The mass of water here was 0.6 kg. You put 0.6 kg here. Then the temperature difference. The temperature of water actually rose from 25 degrees Celsius to 52 degrees Celsius. So you're going to have 52 minus 25, that is 27. So when you multiply this, it will give a value in joules. You multiply this other one, it gives a value in joules. So you add these two together, have a value. Then equate it to this value here. This will be in terms of C. So with that, you can actually work out the specific capacity of the solid in this question. So we're going to use this principle to actually solve some questions. Okay. So that is how it operates. Heat gain by the cold substance is equal to heat lost by the hot substance. As simple as that. So we're going to solve some problems. Before we actually go ahead and solve the problems, in case you need the material, I prepared the lesson notes for this lecture. You can actually request for it, and I'm going to send it across to you. So this is the material. This is the material here. This is the material I've actually prepared for it. So this is the material. Okay. So if you need it, it's available. I'm going to give it to you. Just make your request. So the question we'll be looking at is what is the final temperature which results if 7 kilograms of hot water at 80 degrees centigrade is mixed with 3 kilograms of cold water at 20 degrees centigrade? That is the question we'll be solving right now. So we're going to be solving this. So, okay, so we're going to look at the question now. The question is, what is the final temperature which results if 7 kilograms of hot water at 80 degrees Celsius is mixed with 3 kilograms of cold water at 20 degrees Celsius? The specific capacity of water is 4,200 joules per kilogram per Kelvin. So hot water at a certain temperature is mixed with cold water at a lower temperature. So let's calculate this. I'm sorry for the way my marker is appearing. This is not going to happen in our subsequent class. Okay, I'll get some better markers than this one. Okay, so at the end of the day, we have hot water and cold water. The mass of hot water is 7 kg, 7 kilogram, and the temperature of the cold water, of the temperature of the hot water is 80 degrees Celsius. The specific capacity is 4,200 joules per kilogram per Kelvin. Okay, so for cold water, the mass of cold water is 3 kilograms. The temperature of cold water is 20 degrees Celsius. The specific capacity is still the same value because we are dealing with water. Okay, the specific capacity does not change. Okay, so the specific capacity doesn't change. It remains the same. Since we are dealing with water, water is a substance in both cases. So hot water is mixed with cold water. So the final temperature of the mixture. So what is going to happen is that the final temperature will lie between 80 degrees Celsius and 20 degrees Celsius. This one is going to decrease. This one is going to increase. So let's call that final temperature. Let's call it theta. Let that be theta. So the heat, so we're going to use the process of the method of mixture or calorimetry, which is based on that heat lost is equals to heat gain. So the heat lost by hot water is going to be equals to the heat gained by the cold water. Heat lost equals to heat gain. The one lost by hot water is equals to the one gained by the cold water. Okay. So let me rub up the question. So the heat lost by the hot water is going to be given by MC theta H minus theta, while that for the cold water will be, this is mass of hot water, this is mass of cold water times specific capacity of water times this is going to be theta minus theta cold. So here the mass of the hot water was 7 kilogram times the specific capacity of water times theta H, initial temperature of hot water, which was 80 degrees Celsius, minus the final temperature of the mixture, which we don't know right now, but this is going to be smaller. So the smaller one, the larger value will subtract the smaller value. This is going to drop. This is the temperature of the hot, this is going to drop down. So that's why we're subtracting. Okay, while over here, the mass of the cold water is 3 kilogram times this specific capacity of water, which is 4,200 joules per kilogram per Kelvin, times the final temperature, which we don't know, which we're looking for, minus the initial temperature of the cold water, which was 20 degrees Celsius. This is in bracket. So at the end of the day, I don't want to put this value because this value is on both sides. They will cancel out. If I put it, you will see cancel out. So even if there is a planar value, I can still solve this problem. Okay, but let me just put it for putting sake. But it's not essential. So we have 7 times 4,200 times 80 minus theta equals to 3 times CW times theta minus 20. This is 4,200. So at the end of the day, 4,200 on the left will cancel 4,200 on the right. Why? Because they are at the same level, up. If they were at different level, they won't cancel. Let's assume this was numerator, this was denominator. You can't cancel them. But since they are numerator, they are at the same level, you can just cancel them to make solve your solution process quicker and easier. So we have 7 times 80. This is 560. 7 times theta, 7 theta equals to 3 times theta, 3 theta. 3 times 20, 60. This is 60. So collect like terms. Collecting like terms, we have that 560 minus 60 comes over here and becomes plus 60. So minus 7 theta goes to this other side and becomes plus 7 theta. 560 plus 560 is 620. 3 theta plus 7 theta gives you 10 theta. So at the end of the day, you are looking for theta, which is the final temperature of the mixture. So you divide both sides by 10. So you have 10 theta. So you have to clear whatever theta is carrying so that to make theta the subject of the formula. You make theta the subject of the formula. Since it's carrying 10, this 10 must go away. And the only thing that can make 10 go away, 10 is multiplying theta. So the opposite of what it's doing will clear it away. Since it's multiplying, opposite of multiplication is division. So you're going to divide by 10. So it's going to clear away, disappear. So what you do to the left hand side, do to the right hand side as well. So this is going to be 2 divided by 10 as well. Or no, 620 divided by 10. 10 cancels 10. You are left with theta here. 0 cancels 0. Here you have 62 equals to theta. So the final temperature of the mixture is 62 degrees Celsius. So final temperature of the mixture is 62 degrees Celsius. Okay, so I hope that is clear. I believe that is actually very, very clear. So we've just solved one question in this class, in this lesson, but in the next lesson we're going to solve more. So in case you have any issue, just throw them across and I'll be delighted to assist you. So my WhatsApp number has been provided, +234 8038 295185. Okay, so we are going to continue our calculations in the next lesson. But please, if you're not subscribed to this channel, make sure you subscribe, make sure you like the video and share it with others as well. This lesson can actually help you for any exam, whether JAMB, WAEC, NECO, IGCSE, or whatever lesson you are preparing for. So everything is clear and explicit, well explained. So thank you so much for joining us in this lesson. Well, thank you so much for joining us today in this lesson. I really appreciate you spending your time. So I believe you understood the lesson. In case you have any question, you can forward your question either to my WhatsApp or drop it in the comments section. And please, if you are not subscribed to this channel, go ahead and subscribe. Click on the bell icon so that you always be notified when I upload a new video, and click on the like button, drop your comments as well, and share this video with your friends. So thank you for coming. Let me quickly show you the WhatsApp number. You can connect with me via my Instagram channel as well. You can connect with me via my Instagram channel. You can connect with me via my Instagram channel as well. So this is my WhatsApp number. This is my Instagram channel. So you can also connect via those channels. Thanks for coming. May the God Almighty bless you mightily.